All right, now here we are, Algebra 2, 1-6, the last lesson of the chapter, and the part where we get to bring the last couple sections together, and yeah, we'll bring them together. Here we go. We're going to solve. We're solving compound and absolute value inequalities. So we're going to look at both of those. Compound here is we're going to solve and compound inequalities. So let's look at what are we talking about here. 8 is less than 3y minus 7 is less than or equal to 23. Here's our compound inequality. Now let me show you two ways to solve this. One method is separate these guys separately. So let's do this separately. So when you have a compound inequality, you can solve it like this. 8 is less than 3y minus 7, and then you can also say 3y minus 7 is less than or equal to 23. So you've just taken this, you've taken that part of the inequality, put it there, taken this part, and put it here. So that's all you've done. And now you can solve these individually and then bring them back together at the end. So I'm going to add 7 to both sides. I've got 15 is less than 3y, divide by 3. And then I got 5 is less than y, or y is greater than 5. Let's do this one. Add 7, 3y is less than or equal to 30. Divide by 3, y is less than or equal to 10. So I'm going to find these two values on my graph here and plot those, and then we'll look at method number 2. So I'm going to find 5. So if this is 0, then this is 1, 2, 3, 4, 5. An open circle at 5, because 5 is not included in the solution here. And we're going to look at 10, 5, 6, 7, 8, 9, 10. This is going to be a closed circle because it is or equals to, so it is included. Now let's look at this here to see where we should draw our arrows. Y is less than or equal to 10, so I'm going to go this way. 5 is less than y, or y is greater than 5. So y is greater than 5 and less than 10. Here we go. That is how we're going to shade that in. So that's method 1. And the graphing part of that is going to be similar either way. Method 2, let's look at method 2, and we're going to do these. We're going to solve this together. Now, it doesn't matter to me which one you do, but you just decide which one works better for you and do that way. 8 is less than 3y minus 7 is less than or equal to 23. We're going to start like that, all together. Now, this one can be tricky, but it can be faster. It's just kind of up to you, however you feel, if you feel comfortable doing it or not. I want this y to be by itself. So I want to get rid of this negative 7, so I'm going to add 7. And what I do to this section, I've got to do to all of them. So I've got to add 7 to here, and I've got to add 7 to here. And so now I've got 15 is less than 3y is less than or equal to 23 plus 7, which is 30. Now I'm going to divide by 3 to get that y by itself. Divide by 3, divide by 3. And now I've got 5 is less than y is less than or equal to 10. Now this is what I want your answer to look like, whether you're using this method or this method. So when you're done with this method, you've got to look at it and say, oh wait, 5 is less than y is less than 10. So this should come back together and be 5 is less than y is less than or equal to 10. So this is your final answer here. So this way you're already there. You're ready to go with that. But you have to be very careful and make sure that when you do something here in this middle, that you've got to do it to all three expressions. Same thing here, divide by 3, you got to divide each expression by 3. And that can be kind of, that can be tricky. It's easy to forget to do one of those expressions. This way might be a little bit easier to keep together because you split it up into two separate inequalities. But whichever way you like best, you do. All right, we're going to do a couple of U tries. Negative 12 is less than or equal to 4x plus 8 is less than or equal to 32. And negative 5 is greater than or equal to 3 times a minus 2 is greater than negative 14. So choose a method. You can do either. You can do one on one and one on the other, whatever, and then go ahead and get to work. And then we'll come back and do it together. Remember to graph it at the end. I'll go ahead and pause now. All right, let's go ahead and do this. I am going to do both of these the together method. Your answer should be the same no matter what, but just for time's sake, I'm going to do both of them the together method. So I'm going to subtract 8 from everything, from every expression here. Negative 12 and negative 8 is a negative 20. Is less than or equal to 4x is less than or equal to 32 minus 8 is 24. Divide everything by 4. Negative 5 is less than or equal to x is less than or equal to 6. So there is my answer, and I'm going to draw a number line. I'm going to put negative 5 over here. I'm going to put positive 6 over here. I'll put 0 right there in the middle-ish. These are both or equals to, so they are both solid. Both of these numbers are included, and x is between them. X is greater than negative 5, x is less than 6, or equals to, right? Let's look at this one over here. I'm going to add 2 to everything. Negative 5 plus 2 is negative 3, is greater than or equal to 3a is greater than negative 14, and positive 2 is negative 12. Divide everything by 3. I got negative 1 is greater than or equal to a is greater than negative 12 divided by 3 is negative 4. Now notice I didn't flip any of these inequalities because I divided by a positive number. Even though these are negative here, I still divided by a positive, so I left my inequalities the way they were. So there is my answer here, and I'm going to graph this as well. So I'm going to find negative 4 and negative 1, and then 0 would be right there. And so at negative 1, I've got a is included in there. At negative 4, a is not included. And then a is between these two. So a is greater than negative 4. A is less than or equal to negative 1. So here we go. Okay, great. Now, this was a little bit tricky because we did not solve. We have another box to put right here that's not there, that I didn't include for whatever reason. Here it is. Solve or compound inequalities. And let's see what we're talking about. So here's an example. If I have k plus 6 is less than negative 4, or 3k is greater than or equal to 14. So this is one compound inequality that includes OR. So we're going to graph them on the same number line. So let's solve them individually. Subtract 6. You can't put them together and solve them. You've got to solve them individually like this. So subtract 6. K is less than negative 10. And then I'm going to divide by 3. I've got K is less than or equal to 14 thirds, or 4 2/3. Okay. Let's draw the number line. I'm going to put 0 right here. I'm going to put negative 10 down here. I'm going to put positive 4 2/3 right there. And negative 10 is not included, so that's an open circle. 14 thirds or 4 2/3 is included, so that's a closed circle or solid circle. Now I need to decide which way does my arrow go here. K is less than negative 10, so my arrow goes that way. K is greater than or equal to 4 2/3, so my arrow goes that way. Now I'm going to put a big box around this as my OR compound inequalities section. Let's do an example together besides the one that we did in there. I've got 5j is greater than or equal to 15, or negative 3j is greater than or equal to 21. So I'm just going to solve these and put them on a number line. Divide by 5, divide by 5. J is greater than or equal to 3. I'm going to divide by negative 3, divide by negative 3. J is less than or equal to, see my negative, I've got to flip my sign, less than or equal to negative 7. Get out my number line, put 0 right here. I'm going to put 3 right here. I'm going to put negative 7 over here. Notice how even though I'm not doing a bunch of little dots here, I'm trying to make it roughly, where it would be to scale here. So 3 is included, solid dot. Negative 7 is included, solid dot. Negative 3, j is greater than negative 3, j is less than negative 7. Boom, there is my compound OR inequality. Now let's look on the back here. Oh, there is an OR inequality. All right. I was just missing a page. We're going to fill in this chart. We're going to do a few examples, and we'll be done with our notes for the day. Absolute value inequalities. Now, we're going to write the inequality here. This says absolute value inequality. We're going to write the compound inequality. And we're going to write an example. So if I have an absolute value inequality, that's the absolute value of a times x plus b is greater than c, then ax plus b is greater than c, or ax plus b is less than negative c. Here's an example. If the absolute value of 4x plus 5 is greater than 7, then 4x plus 5 is greater than 7, or 4x plus 5 is less than negative 7. See how I switched my sign and made it negative. I switched my sign and made it negative. Okay, let's look at this. ax plus b, the absolute value of ax plus b is less than c. So notice how this is the absolute value is greater than c. This is the absolute value is less than c. So in this case, I can say negative c is less than ax plus b is less than c. So I have an and statement here. Now, well, let's do this, and then I have a now thing here that you might be interested in. If 4x plus 5, the absolute value of 4x plus 5 is less than 7, then negative 7 is less than 4x plus 5 is less than 7. So remember, when we set up an inequality, or when we set up an absolute value, we had to set up two different equations, right? And so now, with an absolute value inequality, we still have to set up two inequalities now. One is negative, one is positive, or one, but this one, you flip the inequality sign for the negative one. Now, this is showing you if there's a greater than sign here or a less than sign here, that you can go, if it's greater than, you do or, if it's less than, you can do and. Now, what if I forget that? What if I forget which one is which? Don't worry about it. Don't go to this step. Instead, you can do this. ax plus b, you can just set it up the same way, is less than c, and a times x plus b is greater than negative c. So you can do either one of these, it doesn't matter. If you can't remember that less than c is going to give you this whole mess, you can just treat this the same way that you would treat this. But notice how you start with less than a positive, and then you switch the sign and make it negative. With this one, you start with greater than a positive, and then you switch the sign and make it negative. So either way, you start with a positive, and then you switch the sign and make it negative. So you don't have to necessarily remember this. If you do and you want to, that's fine. Or you can just treat them both the same. Let's do an example and a you try and be done with our notes for today. Absolute value of 6y minus 5 is greater than or equal to 13. All right, let's do this together here. So I need to set up two equations, or two inequalities. X minus 5 is greater than or equal to 13. Or it's going to be or, but it doesn't totally matter. 6y minus 5, I switch my sign, less than or equal to negative 13. Switch my sign, switch my sign. So now I'm going to work this out. Plus 5, both sides. 6y is greater than or equal to 18. Divide by 6. Y is greater than or equal to 3. Let's do this one. Plus 5, plus 5. 6y is less than or equal to negative 13 plus 5 is negative 8. Divide by 6. Why can't they just make this easy? Y is greater than or equal to negative 8/6 can reduce or simplify to 1 1/3. So that's 1 2/6, which is 1 1/3. All right, so let's graph this thing. I'm going to put 0 right here. I'm going to put positive 3 right here. I'm going to put negative 1/3 right here. Negative 1 1/3. Negative 1 1/3. Okay, now this 3 is included, solid circle. This negative 1 1/3 is included, solid circle. Okay, y is greater than 3. Y is greater than 3. y is less than negative 1/3. Y is less than negative 1/3. So when you've got the arrows going the opposite direction, you know you have OR going on because the arrows are going opposite directions. Now let's do a U try. The absolute value of 5a plus 2 is less than or equal to 17. So before you get started, the last one was greater than, and so we had an OR situation. This one is less than, so you have an AND situation. You can go straight to here if you want, or you can do this, and you should still end up with the same answer. So it's up to you. And go ahead and pause and get started. All right, welcome back. So I'm going to set this up 2 different ways, just so you can see that they both work, but I'm only going to go through one of them. So as we learned from above, this is an AND situation. So that means I can just take this negative 17 and say is less than or equal to 5a plus 2 is less than or equal to 17. Because that's less than. But who's going to remember that? So you don't need to do it this way if you don't want to. If you remember that, cool, go ahead and do it. If you don't do it that way because you don't want to get confused and do that with the other one that's on top. So we can just take this, move it over here and say, I'm going to say 5a plus 2 is less than or equal to 17 and 5a plus 2 is greater than or equal to negative 17. Switch my sign, switch my sign. Okay, so then I just say minus 2, 5a is greater than or less than or equal to 15, divide by 5, a is less than or equal to 3. Oops, I forgot to write 2 right there. Subtract 2 from each side of this one. 5a is greater than or equal to negative 19. Oh wait, did I do something wrong? Two 15. Yes, no, I didn't. Okay, that looks weird. All right. Then I divide by 5. A is greater than or equal to negative 19/5. Gross. Negative 19/5 is 5 goes in there 3 times, and there's 4 left over. Negative 3 and 4/5. Goodness, why would they make this? Okay, here's my graph. Here's a 0. Here's negative 3/4, 3 and 4/5, and here is positive 3. Both of them are included, and this is AND, so we're going to shade in the middle, but let's just check and make sure. A is less than or equal to 3, so I'm going to go that way. A is greater than negative 3 and 4/5, so yes, I am right. This is an AND statement. I can treat both of these the same way. Whether it's greater than or less than, I can treat them the same way. If I remember and want to do the less than, the AND version, this way, you could do that if you want. You're going to end up with the same thing. And let's rewrite this. Since now I know that they're AND, let's rewrite this as negative 3 and 4/5 is less than or equal to A, which is less than or equal to 3. So this is the right way to write this, and the graph is there. And that is the end of 1-6.